Awesome. All right. So looks like we're recording now. What we're just going to be working on today is we got a six-sided die here. You know, I got this from a Monopoly set, I think. So that'll be fun to see how fair Monopoly is, as long as this is actually a properly weighted die. So what we're going to be doing with it is just conducting a chi-squared test to see if it falls into the expected range of outcomes. I'm just going to be writing it down here on the notebook. I got my calculator right here. And so because it is an equally or expected to be an equally weighted, and we are doing 100 test trials, generally what we're going to want to see is about 17 outcomes for um, each possible outcome, or 17 amount. How do you say that? Okay, anyway, what I mean is we're going to see one 17 times. We're going to see four 17 times. Each outcome is going to have an equal amount of times. That's what I mean. Forgive my words. I just got through finals. I'm tired. But anyway, so what we're going to do now is just record each of the dice throws. I'm gonna try and make them land on my mouse pad because it's this table is loud. I'm not trying to disturb people, but I'm gonna write them down. We're gonna find the averages, and then go from there. And here adjust the camera a bit. All right, so let's get started. That's falling a lot, but we are starting off with a 1. We got a 5, and here I might actually number this real quick. 4, 5, 6, 7, 8, 9, 10. 16, 17, 18, 19, 20, just so I don't lose track, because I am absolutely the type of guy to lose track. So we have 25 there, so let's say we're just going to split my notebook into 4s, so that way this goes a little easier for me. There we go. Okay. Sorry. So let's continue on with number 3. We have 6. We have a 5 again. 5 again. How are you getting so lucky? Oh, that's a 2. Move my mouse out of the way so I don't hit that anymore. A 1. We have a 2. 2. 5. We're a tenth of the way through. We have a 3. 2. Sorry, everyone. That was loud. 5. That's trying to keep down the mouse pad if I can. I'm just put my jacket around here. It might help with the sound. I don't think it's too bad, but there's a lot of 5s in here. I'd be getting so lucky if I was playing, like, if you ever played Risk. That's like one of my favorite board games to date. It's old, but God, I'd be sinking so many countries right now with these dice throws. We got a 1 there. It's a 6. All right. It's a 4. We got a 5. A 3. And we have another 3, and that makes us 1/4 of the way there. We have a 5. Number 2. We have a 5 again, and this isn't the fun part. The fun part's going to be watching me count up all the different results. That was a 6. We have a 3. 5. We have a 4. 6 again. Just try rolling this on the notebook itself. We have a 4. Oh, actually works pretty well. 5. Okay, we're not going to count that one. That was by my hand. Okay, here, real quick, we're going to try and put the jacket down so that way it's not. I can at least kind of keep it from rolling onto the table. Okay, 6. Because I'm really trying not to keep it like bouncing around people. That's a 6. Of course, it goes the other way, right? All right, we're going to redo that one. That was all right. 3. I might just have to roll it lower to the ground. 5. I don't want this jacket. 3, 5, 4, 4. We have another 4. 1 again. I haven't seen 1 in a while. This is going to be interesting to observe. We have a 5. Oops, that's a 6. 3. We have a 5. And 6. Okay, we are halfway there. We got 50 trials done. We have a 3, a 4, 1, a 5, 5 again, 1. I feel like I haven't gotten many 2s. No, we've got some 2s. This is a 1, 5. Might just be recency bias. I don't know. We have a 6, 1. All right. Far, it's a 4, 1 again. I was complaining about 1s, and now we're starting to get a ton of 1s. So there you go. That's a 3, 6. We have. Damn, it keeps throwing off the thing. I have a mouse pad for a reason, and it just keeps going off it. It's a 1, though. It's a 5. Okay, stay here. 5. There we go. We have another 5. I swear I'm going to sound crazy if it's not even picking up like the loud sound the dice makes on the table. We have a 4th 5 in a row. Wow, I am lucky. That's a 2. All right. That's another 5. We have a 3. It's another 3. And we have a 5. Who would have thought, right? So we are 3/4 of the way there. We got 75. We got 4. 5. We have 4 again. 5. 4. 5. 5. That went kind of far. Oh, you can't see the dice on here. That's fine. We got a 4. We have a 2. A 4. We have a 4. Come back here. A 1. Bounce onto the notebook. That's awesome. 5. We have a 3. Maybe the left hand was just right all along. 5. 6. 2. 1. 2. Drop that. 2 again. We have a 1. Someone just honked. That's funny. 5. 6. 3. And last one. It is a 6. All right. So just to show off the line of data we have. Oh boy. Like I said, the fun part's now going to be actually counting out how many outcomes we have of each possible outcome. So now this is the fun part. So going to start off with 1. We're going to count off all the ones we have. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so we have 13 ones, which the second quarter really saved, or no, not second quarter. I think third quarter really saved the ones for that because first half of it we weren't really getting anything for that. I think it was about 5. But anyway, I'm gonna continue on. We have number 2 now. We're gonna count out. Which I have a feeling 2 is gonna be our lowest, but 2, 3, 4, 4, 5. I hope my pen's not dying. 5, 6, and it's kind of dying. 6, let's see. 7, 8, 9, 10, 11. Looks like that was it. 11. Okay. And I just remembered. I will go on with the null and alternate hypothesis. I'm going to write them down here. I just wanted to get the counting out of the way first, but just so I can yap about it for a second. The null hypothesis is essentially going to be that each outcome is going to fall into it's 1/6. What's 1/6? I don't remember that off the top of my head. About 17%. So each outcome is going to have a 17% range. And so the null hypothesis is going to be that for 100 dice throws, we're going to see that generally around that range. And then the alternate hypothesis is going to be, well, it falls out of that range. And so I'll write it down here and I'll submit it, obviously. But that just came to my mind that I definitely want to verbalize it. Can't think of words today. Well, with that out of the way, let's go on to 3. I think we're going to see a lot of 5s and 6s probably. They seem to be a lot of what I was getting, but we'll see. All right. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, cool. I know we have a very general range so far. All right, let's go on to 4. 1, 2, 3, 4, 5, 6. Oh shit, I lost count. Hold on. Real quick, let me restart that. We had 1, 2, 3, 4, 5, 6, 7. Yeah, don't ever take your eyes off the paper. Learn that one the hard way. 8, 9, 10, 11, 12, 13, 14, 15, 15. Reaching there. Oh boy, number 5. It's gonna be like 30,000 or something. Anyway, let's start. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 2, 23, 24, good Lord, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34. All right, well, my prediction when I was counting this was right. I was going to get a lot of fives. I was joking when I said like 30,000, but that's crazy. Okay, anyway, that aside, let's finish this up. We got 6. So 1, and I know I could just subtract it and find 6. I want to make sure after I count everything that everything adds up to 100, so that way I didn't miss anything. So that's just the reasoning behind me going through this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, so let's add this up real quick just to make sure. 13 plus 11 plus 14 plus 15 plus 34 plus 13 at the 100. And that is insanely skewed towards 5. So here, I'll let you take a look real quick at what we got so far. I know that's reversed, but sorry. Anyway, so we're just going to be comparing this now to our expected charts. So the chi-square are here. You know what? I'm going to write down real quick what our null hypothesis is versus our alternate hypothesis. So we'll say that, how do you want to write this? We could say each outcome corresponds to the expected. I mean, I feel like that's general, but yeah, we'll do that. We'll say each outcome corresponds to the expected weight, and we'll say 17%, because that was calculated to be 1/6. A die should be equally weighted. Each outcome should be 17% likely to happen. And so the alternate hypothesis will be we'll say there is at least one outcome that doesn't correspond to the expected weight, 17%. Okay. There. If y'all are learning to read backwards, that's what we got. And so I'm going to go flip the page, and we're going to just write out our, this thing would flip. We're going to write out our tables. So just 1, 2, 3, 4, 5, 6. We have our, call it O of X, and then E of X, where E of X is super easy. It's just going to be, make sure 17 times 6 is, that's actually 102. Ooh, is it 16.7? I guess if you round it like that, well, it's like, but then that goes to, we're going to work with decimal places, I think. For this experiment, there's a 16.67, 67 times 6. We're gonna work with decimal places for this. I know you can't technically have 16.67 rolls, but just for the sake of this experiment, I feel like I feel like it's better to do a decimal roll than to sum to 102 expected values when we only did 100. So that's just the reasoning behind that. I'm gonna just write that in, but just so y'all kind of get my understanding there. So we're gonna do 16.67 for each expected value. And then go back real quick. We have 13, 11, 14, should be 15. We could forget 34, and then 13 at the end. So that's our new chart. We have our expected on this side, all 16.67. We have 13, 11, 14, 15, 34, and 34 there. Okay. So now to find, let's do our critical statistic first, just to make that easier. So the chi-squared fitness test, we are comparing essentially the test statistic, which we're finding through our observed and expected results, but then we're also comparing our critical stat. And our critical stat is so much easier to find because it's on a chart. And so all I really need is degrees of freedom, which degrees of freedom for this is just going to be n minus 1, where n is the amount of outcomes we have. In case you haven't been paying attention, our outcomes are 6. And so 6 minus 1 is 5. Our degrees of freedom is going to be 6 minus 1 equals 5. So that's what we're going to be searching for. And then as well as that, our alpha was specified to be 0.05. So when we're looking on the chart, we're going to be looking for, I think it's Q on the chi-squared chart. Let me pull that up real quick. The mouse work? There we go. All right. So where did I put that thing? Okay. So yeah, it is Q. So it's going to be Q 0.95 at degree 5, which is going to correspond to 11.07 as our critical stat. And where's the camera? So that way I make sure I'm not looking stupid. Okay. So yeah. So our critical stat that we're going to be comparing to is 11.07. And so generally then, we're just going to be comparing our expected value, our test statistic. If our test statistic is, if it's greater than the critical statistic, then we can reject the null hypothesis that this all falls into the expected range. If it's lower than the critical statistic, then we cannot reject it, and so it falls into the range. And that's just the logic behind it. So all we have left to do, excuse my words again, is just sum these up using the chi-square formula. Call this test stat equals, oops, I'm gonna write this down wrong on video. That's gonna suck. Be really embarrassed there. I just I wrote an E as the sigma instead. I mean, this is backwards anyway. You guys aren't reading this. All right. Anyway, but yeah, we have our test statistic is just going to be the sum of the observed value minus the expected value squared over the expected value. If you guys, yeah, want to see that a little better. So we're just going to be doing that for each iteration. We're just going to do this 6 times and then sum them all up, and that's our test statistic. So I'm going to write that down real quick. We're going to start with number 1. We have our observed is 13 minus 16.67 squared over 16.67. I don't know what this magical number is going to be. Squared over 16.67. Coming out to about 0.81. We'll just sum it up to 2 decimal places there. Number 2 is going to be 11 minus 16.67 squared over 16.67. Just realize how easy it is conceptually to have the same expected value. When I would do this on other problems, I'd always get the expected value and the observed mixed up for the denominator, and it'll always be such a pain in the ass to figure that out. Anyway, we have 11 minus 16.67 squared. It's 32 point something something. We'll figure out the decimals in the division. So final answer, we have 1.9, and I'm rounding that to 9.3. All right, so there's 3. We have 14. 14 minus 16.67 squared over 16.67. 7, that's squared. We have it over 16.67. We are rounding this 0.43. All right, number 4 now. A line there just for sake of grading. It is 15 minus 16.67 squared over 16.67. Let me actually write that down so I don't look crazy. 67 squared over 16.67. We're rounding this to 0.17. Awesome. Okay, so number 5. 34. I'm curious to see this one. Minus 16.67. This can be a big outlier. I'm expecting this will take us past the critical stat, but that remains to be seen. 4 minus 16.67 squared. Oh, yeah, that's absolutely taking us. I think this one on its own puts us past. This one is 18 point, and we'll round it to 0.02. So that actually by itself takes us past the critical stat, which is hilarious. But I'm obviously going to complete the calculation. But yeah, if you'll remember, our critical stat was 11, and number 5 on its own is 18. So that's pretty insane. But here, let me finish it out with 6, and then we'll just write out that final conclusion. But yeah, that is such an outlier. I'd be so lucky playing Monopoly. All right. Anyway, so 13. We have 13 minus 16.67 squared over 16.67 squared over 16.67. And this is going to round to 0.81. All right, so our summation now is going to be 0.81 plus 1.93 plus 0.43 plus 0.17 plus 18.02 plus 0.81, which we come out to a whopping 22.17. It's about double our test or crit stat. Getting my words mixed up again. Just label that. So We'll just write out a conclusion here. Test greater than crit because 22.17 is greater than 11 point, was it 17? 07, right? Yeah, 07. 07. Therefore, we reject the null hypothesis, which was that it falls into the general framework of equal weighting, which is 17%. So yeah, here you'll want to see the calculations on that side. But yeah, that was very weighted towards the 5. And then yeah, this is our final conclusion. Basically just what I was saying, just written down. But yeah, there we go. So Monopoly is very unfair, and this die is going to cause a lot of family arguments, which is why I'm going to immediately go home and suggest we play Monopoly. All right. And let's stop this recording.